Hello everyone, Andrew Glaser here from the Glaser Tutoring Company, and today I would like to teach you how to use the Rational Zero Theorem to find the real zeros of this polynomial function. So first thing is, well, what in the world is the Rational Zero Theorem? Well, it basically says that if you find the factors of your constant term in your polynomial, call it p, and you find then the factors of the coefficient of the leading coefficient, they call it, of the highest power of x, call them q. If you then take those factors p, divide them by those factors then q, that will give you the list of possible real zeros. Okay? Possible. Now, let's list out then the factors for your constant term. Now, every factor is going to be positive and minus. Okay? Plus and negative. Positive and negative. So what are the factors of 6? You got to think about whole numbers that multiply to 6. So you definitely have 1 and 6. That's easy, right? And you also have then 2 and 3. So these are the factors, and each one comes with a plus and a minus. Then for your q, which is, right, the factors of 3, you do the same thing, and the factors of 3 are going to be just 1 and 3. Right? Those are the whole numbers. Okay. Now, when you create now the list of possible values, you have to now take each numerator individually and then divide it by each denominator individually. So in other words, here you would have one possibility, plus or minus 1, divided by plus or minus 1, and that gives you a plus or minus 1. So that's one set of possible real zeros. Then you would do the same thing for the next. So then you would take your plus or minus 2, and then you would divide it by your plus and minus 1. And when you were to do that, right, then you would get plus minus 2 over plus minus 1. And that'll again arrive at a plus minus 2. And you would keep doing this, right? Then you would do the 3 and the 1, so that'll give you a plus minus 3. Then you would do the 6 and the 1, then that'll give you a plus minus 6. And then you got to repeat the process. Okay, so let's just clean up these circles here. What's going on? There you go. Now you have to repeat that process, and you got to take this numerator over that denominator. So that's 1 over 3, and that'll result with a plus minus 1 over 3. Same thing. Write the 2 and the 3, so that'd be plus minus 2 over 3. And you kind of see where this is going to go. This is going to go to a place where I don't even want to go. This is plus minus 3 over plus minus 3, right? That's going to be a plus minus 1, but you already have that up here, so you don't have to write that down. And then you're going to have a plus minus 6 over plus minus 3, which would give you plus minus 2, but you already have that over here. So basically now, you have 6 sets of plus minus, which means you have 12 different possibilities. Right? 12 different possibilities here. So, but you know that at a max, this is a cubic function. So at a max, you're going to have 3 at a max, but you got 12 in your list. So what that means is that we're going to have to do a little bit of a guessing and a checking to try and use this Rational Zero Theorem to try to really help us out. Okay? The idea now is that what you can do, so let me just erase this. The idea now is that one of these 12 values, I know there's 6 on the page, but remember they're both plus minus. One of those 12 values, when plugged into this function, or possibly 1, possibly none, possibly 3, we don't really know right now. Do you have any idea which one of these 12 is going to work out? Or any 3 of those 12? Or none of them? I certainly don't. Definitely not just by looking at it. So watch. What I got to do, I'm just going to do it with 1. So what I got to do is I got to throw 1 in here. Okay, I'm going to use positive 1. And I'm going to see how the math works out. Okay, if then the math works out here in such a way where this does indeed equal 0, that's what I'm trying to check, then I know that positive 1, the number I plugged in here, will be a 0 of the function, meaning it's an x value that produces a 0 for the function. So this is 3 minus 1 minus 11 minus 6. This isn't really looking too promising for it to equal 0, right? And what that means now is positive 1 is not a 0. Great. We got 11 to go. So now you can keep testing. All right, but this is this is very inefficient. So I wouldn't really recommend I wouldn't really recommend it, using this really. Honestly, you got to know the theorem, but are we really going to use it? Probably not. So go to your calculator and plug that function on in. So we're going to do 3x raised to the third, and then it's going to be minus x squared, and then minus 11x minus 6, and graph it. All right. Now this is going to give us a little bit of a better idea, maybe where we should be looking. Okay. So the zeros, remember, when you look at a graphical picture, the zeros of the function are the values of x where the function crosses this x-axis, right? So it's going to be right here, and right here. So it looks like now I might want to test, this value looks a little greater than 1, negative 1 that is, right? A little greater than that. So do any values here look a little greater than negative 1, but less than negative 2? I don't think so, right? I don't see anything. So what that means is that that 0 is not going to be found by using this theorem. How about this one then? This is a little, now I guess greater than or more positive than your negative 1 value. So do you see something that might be a little bit more positive than a negative 1? And I kind of do, right? I have two values over here that might work, the negative 1/3 and the negative 2/3. This definitely looks closer to a negative 2/3, right, than a negative 1/3. So I'm going to just write that down. I'm going to say maybe x is going to be, one of the zeros is going to be negative 2/3. We'll test that then using the rational zero theorem. And then this value here looks like it's greater than 2, some fraction, right, or some decimal. Greater than positive 2. Do you have any fractions or decimals greater than positive 2? I don't think so. So guess what? This one isn't going to show up as well using the rational zero theorem. So what that basically means is that you had 12 possibilities over here, and only one of them was going to work. So, you got a 1 in 12 shot when you first start selecting numbers, and I don't think you would have started with negative 2/3. But that will probably work out. So let's see. Ready? So now what I'm going to do is I'm going to take negative 2/3, and I'm going to plug it in everywhere I see my x. This is exciting. How's your year going in school, or your semester in college? Hopefully it's going well. Hopefully these videos are helping. That doesn't equal 6. That's what happens when I talk and write. Good thing it doesn't happen when I talk and walk. Otherwise I wouldn't be going anywhere. Anyway, all you have to do now is plug, you can plug this on into the calculator, and look, I made another mistake. Maybe I shouldn't speak. Okay, the rest of the video I'm just going to go mute. I'm kidding, that'll get really boring. So 3 times then, I'm going to do a negative 2/3. Make sure you use parentheses here, raised to the third. Minus then, parentheses, negative 2/3. Okay, you can just do 2 divided by 3, close the parentheses and square it. Then do minus 11, open those parentheses and do a negative 2/3 again. And then do a minus 6. And voila, it equals 0. That's what the rational zero theorem basically says. That this was a fraction of one of the factors of the constant term, one of the factors of the leading coefficient, plus or minus, and that one did work, negative 2/3. So this is a 0, right, of the function. Now, no other value is going to work. Okay, no other value is going to work. So now what I want to do is I want to, and what we need to do, because I know no other value is going to work, I have to now somehow use this 0 value, all right, this 0 value, to find maybe, or do a division, maybe a synthetic division. So I can try to break this now down maybe into a quadratic. I know I'm dealing with a cubic, right? Factoring cubics are kind of ridiculous, but factoring or finding the zeros of a quadratic are a lot easier. So I know if this is a 0, remember, this is the idea. If I know that this is a 0, then I also know one of the factors of this polynomial. The factor would be x plus 2/3. Okay, right? Because if you set this thing equal to 0 to find then the 0 value of x, you would have subtracted, and that's what it would have equaled. All right. So basically what I'm going to look to do is I'm going to look to take this polynomial function right here, forget about that, it equals 0, and I'm going to divide it then by the x plus 2/3. since this is a linear function down here, I can use synthetic division. All right, and let's do it. Bam. So in this table, I'm going to put in these columns the coefficient of my x cubed term, x squared term, x term, and the constant term. So the coefficient of the x cubed term is going to be a 3. Coefficient of the x squared term is going to be a -1. X term is a -11, and the constant is -6. Great. Then what I'm going to do is I'm going to take the denominator, set it equal to 0, solve it for x, and then plug in that value. I already have it over here. So basically what you do when you do a synthetic division is you take this 0 value and you plug it on in, so -2/3. Then what you're going to do is just follow this simple series of steps. I'm going very quickly through the synthetic division because at this point, if you're doing this type of a problem, you must have already covered synthetic division. And if that's a little rocky, I have 20 videos or so probably on synthetic division, maybe even more. I don't quite remember, where I go painstakingly slow, all right, and teach you the process. So check out those videos in the playlist, all right, on my channel. Now, we're going to take the bottom number here, multiply it by the outside number there. So -2/3 times then 3. The 3's cancel, so that's just a -2. So you plug in that value here, -2. Then you add this column on up, so that's going to be a -3. Now you do the same thing, -3 times the -2/3. I already know that it's going to work out to be a +2 because of what we did prior with the +3. Add this column on up, so that's going to be then a -9. Then you're going to take the -9, multiply by the -2/3, times then 9. And 1 second, oh, I am receiving a phone call. Give me 1 second. And I'm back. Sorry about that. So now what we're going to do when we finish up this multiplication, don't forget that it's a -9, and you're going to reduce this on down, so that can reduce down to a 3. Then it's a -2 times a -3, which is a +6. Add that column on up, and oh, look, it's a 0 remainder. That's what we should expect. If this is a factor, right, thinking about the remainder theorem, that if this is a factor, when this factor is divided into this polynomial, the remainder should be 0, which it is, right? So we know it's a factor, and therefore we know the 0. Now, don't forget what these values at the bottom of your synthetic division table represent. This represents your constant term, this represents the coefficient of the x term, and that represents the coefficient of the x squared term. It does not follow the same pattern as the top row. So what this now means is that this is really my resulting quotient, or the polynomial that results from this division that we did is going to be 3x squared minus 3x minus 9. Now what we can do is we have techniques to now find the zeros of this. Okay, we have techniques. So why don't we do that? Let's take a look. Okay, so now that we have a quadratic, you have to remember that there's always going to be this particular method you can always use to find the zeros of this quadratic. It's known as the quadratic function, right? Or the quadratic equation, whatever you want to call it. So this is -b, x is going to be equal to -b plus or minus b squared minus 4ac all over then 2a. Remember, the a is the coefficient, the leading coefficient. The b is going to be the coefficient of the x term, and the c represents your constant. So that means that the value of b, always plug in then the values in parentheses, is a -3 plus or minus the square root of your b squared, so -3 squared, minus then 4 times your a, which is a 3, times your c, which is going to be a -9, all then divided by 2 times your a value of 3. So simplify the numerator. Okay, so this is going to become a +3. That's going to be plus minus then the square root. So -3 squared is a 9. Then you're going to have 4 times 3, right? So that's going to give you, well, that's negative. This whole thing is going to be positive overall because it's a negative times then a negative and a positive, right? So that's going to be a positive overall. Then do 4 times 3, which is going to be 12. 12 times then the 9 is going to be a 108, right? And let's just double check that. Okay, good. Whew. Then you can combine these two now, right? And when you combine 108 and 9, you're going to get 117. Okay, 117. And that's all then going to be divided by now 6. Now the 117 is a strange number. I'm going to see if there's any whole numbers that I can or perfect squares in there. I don't think so. I don't think there's going to, maybe 40. No, that's definitely not going to work. I don't think there's going to be a nice number that's going to divide into that. All right. So you can basically leave it in this form now because you can't really factor out a term there. Yeah, I think, I mean, you could do like, I think this is probably going to be good enough. So you're going to get a value of 3 then plus radical 117 all over 6. And you're going to get a value of 3, that's a 6, 3 minus radical 117 all over 6. So these are going to be the two additional now zeros. Like I said, you should have you'll have a maximum of 3 real zeros, right? And these are going to be the other two values. So now what you can do is you can use this program in the calculator to just check yourself when you're talking about the quadratic, all right? You're going to love this thing. Watch, take a look. Hit program, all right? I have a video. I'll leave you a link in the description below to it. It'll take you 3 minutes to program your calculator with this thing. Plug in your A value, which was a 3. Plug in your B value, which was a -3. Plug in your C value, which was a -9. And voila, here are the zeros, 2.3 and -1.3. Now, if we go back to the graph, right, doesn't that look, I don't want the second. Doesn't that look like like what it should have been, right? Let me blow that up a little bit. Doesn't that look like it's about -1.3, and doesn't that look like it's maybe about +2.3? Yeah, it kind of does, right? Interesting. Okay. So now let me quit that, and let's plug in then these values, and the calculator gives it to you in decimal form. But now what I'm going to do is plug this in and just see if I'm right with one of them. So let's do 3 plus then radical 117. Okay. I guess I should be using parentheses. So go back, insert then the parenthesis over here. Make sure the whole thing is in parentheses when you do your division, otherwise it's not going to work properly. You got to divide the whole numerator by 6, hit enter, and look at that. It's exactly the same. So I know I'm good. All right. So the 3 zeros now, the 3 zeros of this problem are going to be the x equals -2/3, and then these additional 2. Guys, thanks so very much for tuning in. I appreciate it very much. I really do hope this video helps, and if it does, please like and subscribe. We'd appreciate it so very much. And I look forward to helping you with more problems. And check out our channel because we have thousands of videos out there, not only in math, but physics and chemistry as well. We solve specific problems. That's the best way to practice. You have to understand a little bit of the theory, but then you got to do a ton of problems. And instead of just having an answer for them, you have a method of how to solve them. So we really try to provide as much help as possible. Thank you so very much. Take care.